Assalamu alaikum. Our next video is related to the balancing of equation in acidic media. We have already uploaded two videos related to the balancing of equation in aqueous acidic media. It is the third one, equations, but extra thing which is attached to this balancing of equation is the calculation of the EMF of the cell, Gibbs free energy, and equilibrium constant values of this equation after balancing. First, we focus on the balancing. After that, we will calculate the cell potentials, change in Gibbs free energy, and equilibrium constants. The method is the same. First of all, we separate the two cell reactions, which are called half reactions. One is the oxidation half reaction, other one is the reduction half reactions. In these equations, H2SO3 is oxidized to SO4 sulfate ions. This means it is the oxidation process, because that is the gain of oxygen. There is a 3 oxygen. On the right hand side there are the 4 oxygen. It means that is the oxidation process. We start to balance this oxidation half reactions. First of all, you balance the sulfur, then oxygen. Balance the sulfur, then oxygen. Okay. Sulfur are the same on the both sides, but oxygen is not same on both sides. Okay. Other one is the reduction reactions, in which iodate ion change into iodine, in which first we balance the iodine, then we balance the oxygen on the both sides. Let's try. First of all, we balance the reduction half reactions. Put the 2 on left hand side to balance the iodine on the both sides, then balance the oxygen. To balance the oxygen, you put the 6 water molecule on the right hand side, because 2 multiplied by 3, there is the 6 oxygen. To balance the 6 oxygen, we multiply with the 3 and 6 oxygen. 6 oxygen. To balance the 6 oxygen, we put the 6 water molecule on the right hand sides. As a result, 12 protons are produced. To balance the 12 protons, we put the 12 proton on the left hand sides. Now at the last, after balancing oxygen, hydrogen, we know that at last we balance the charges. 12 protons mean 12 charges on the left hand side, plus 12 charges, and iodide ions have a minus 2 charges. Per iodide ion have a minus 1, and 2 iodide ion minus 2 charges. It means on the left hand side there are the plus 10 charges. On the right hand side there is the 0 charges, there is no charge. To balance the charges on both sides, we know that in the reduction of reaction we put the electron always on the left hand sides. To cancel out this plus 10, we put the negative 10 on the left hand side. Negative 10 and plus 10 cancel each other, and in this way 0 charges on the both sides. Okay. It's mean if we put the negative 10, as a result of that negative 10 we put the 10 electrons and the left hand sides. Next we balance the oxidation half reaction. In the oxidation half reactions we see that in on the left hand side there are the 3 oxygen, on the right hand side there are the 4 oxygen. It's mean on the right hand side there is 1 extra oxygen. To balance this extra oxygen we put 1 water molecule on the left hand sides. On the left hand side we see that there are the 4 protons, 4 hydrogens. To balance these 4 hydrogen we put the 4 protons on the right hand side. Now after that we balance the charges. After balancing sulfur, oxygen and hydrogen, at the last we balance the charges. On the left hand side there is the no charge, 0 charge. On the right hand side plus 4 charges and negative 2 charges. It's meant to plus 4 charges plus 2 charges are present on the right hand sides. Okay, and to balance these plus 2 we put the negative 2 on the right hand side because we want to balance the charges on both sides, because left hand sides there is the 0 charges and we want to maintain the 0 charges on the right hand side, and we put the negative 2 on the right hand side. In place of negative 2 we put the negative 2 electrons on the right hand side, because in the oxidation reaction we put always 2 electrons on the right hand 2 electrons on the right hand sides, because it's the oxidation reactions. Okay, what is the problem is created? We have already discussed that gain of electron and loss of electron must be equal. In the reduction half reaction there the 10 electrons are gained, but here the 2 electrons are lost. How we balance this? To balance this we multiply this section, this portion, this half reaction with 5 multiplied by 2, 10. In this way loss of electrons and gain of electron will be equalized. When we multiply with 5, whole half cell reaction will be multiplied with the 4. In this way 10 electrons are gained and 10 electrons are lost are equal. 10 electrons and 10 electrons cancel each other. After that on the left hand side there are 5 water molecule, on the right hand side there are 6 water molecules. If we cancel these 5 water molecule with the 5 water molecule, 1 water molecule remain, then see no other parts can be cancelled out, right hand side and left hand sides. At the last all the species of equations of both reduction half reaction and oxidation half reactions which are on the left hand side put on the left hand sides, and all the species which are present on the right hand side of the arrow put the right hand sides. In this way we have balanced the equations. Next we will calculate its Gibbs free energy, equilibrium constants and cell potential.